Imagine you're standing on a beach 252 million years ago. The sand beneath your feet is warm, the ocean stretches endlessly before you, and life is absolutely everywhere. Trilobites scuttle across the seafloor, massive amphibians patrol the shallows, and towering forests of strange, scale-leaf trees stretch as far as the eye can see. This is Earth at the end of the Permian period, and it's about to become hell on Earth. What you're witnessing is the last moment of normalcy before the most catastrophic event in the history of life itself. In just a few thousand years, 96% of all marine species will be gone. 70% of land animals will vanish. Entire ecosystems will collapse so completely that it will take 10 million years for life to recover. This is the story of the Great Dying, the Permian-Triassic extinction event, and it makes the asteroid that killed the dinosaurs look like a gentle spring shower. But here's the terrifying part. We're still not entirely sure what caused it, and some scientists believe we might be recreating the same conditions right now. The year is 252 million years ago, and our planet looks nothing like the world, you know. There are no polar ice caps, no grass, no flowers. Instead, imagine a supercontinent called Pangaea, a massive landmass that stretches from pole to pole like a giant scar across the planet's surface. The interior of this supercontinent is a scorching desert, while its edges teem with bizarre life forms that seem almost alien to our modern eyes. In the oceans, creatures called brachiopods filter nutrients from the water with shells that look like ancient castles. Crinoids, or sea lilies, wave in the currents like underwater forests. And prowling through it all are the ammonoids, spiral-shelled predators with tentacles that could grab prey with lightning speed. On land, the dominant predators aren't mammals or dinosaurs, but something far stranger. Therapsids, creatures that are neither quite reptile nor quite mammal, with features of both. But beneath this thriving world, something sinister is stirring. Deep in what is now Siberia, the Earth's crust is beginning to crack. Magma chambers the size of small countries are swelling, pressing upward with unimaginable pressure. The ground trembles with earthquakes that would register off any modern scale. And then, with a violence that defies comprehension, the planet begins to tear itself apart. Picture this. Fissures hundreds of miles long split open across Siberia like wounds in the Earth's flesh. From these cracks, lava doesn't just flow. It explodes outward in fountains of molten rock that reach into the stratosphere. The sound is beyond anything you could imagine. A roar that would be heard on the other side of the planet if there were anyone left to hear it. But the lava is just the beginning of the nightmare. As millions of cubic miles of basalt pour across the landscape, something even more deadly is being released. The magma is burning through coal deposits, oil shales, and limestone formations, releasing clouds of carbon dioxide, methane, and hydrogen sulfide into the atmosphere. The sky begins to change color, shifting from blue to a sickly yellow-brown as sulfur compounds react with water vapor to create acid rain that could strip flesh from bone. The numbers are staggering. The Siberian traps, as geologists call this volcanic catastrophe, pumped out enough lava to cover the entire continental United States under a layer of rock nearly half a mile thick. The amount of carbon dioxide released was equivalent to burning all the fossil fuels humans have ever used, multiplied by 1,000. And this continued for thousands of years. At first, life tries to adapt. Some creatures might have even thrived in the changing conditions. But the planet is transforming too quickly, too drastically. The massive amounts of carbon dioxide and methane in the atmosphere create a runaway greenhouse effect. Global temperatures spike by 18 degrees Fahrenheit in some regions. The polar regions, once temperate, become blazing hot. The equatorial regions become furnaces where no complex life can survive. But temperature is just one killer in this perfect storm of extinction. The the oceans begin to absorb the excess carbon dioxide, and something terrifying happens. They become acidic. Imagine trying to survive in water that's essentially become dilute acid. Creatures with shells and skeletons made of calcium carbonate start to dissolve alive. The beautiful spiral ammonoids, the filter-feeding brachiopods, the reef-building organisms that created underwater cities of life, they all begin to disintegrate. And then the oceans start to die. As temperatures rise, the solubility of oxygen in seawater decreases. The warm, acidic oceans can't hold enough oxygen to support most marine life. Dead zones expand from the bottom up. First, the deep ocean becomes anoxic, completely devoid of oxygen. Then the dead zones creep upward, eventually reaching the surface in some areas. But there's an even more sinister process at work. In the oxygen-starved depths, bacteria that don't need oxygen begin to thrive. These ancient microbes start producing hydrogen sulfide as a waste product. Hydrogen sulfide is the gas that makes rotten eggs smell so terrible. But in large quantities, it's a deadly poison that can kill complex life forms instantly. Picture the horror. Purple and green clouds of toxic gas bubbling up from the ocean depths, killing everything they touch. Fish, marine reptiles, and even microscopic plankton die in massive numbers. The hydrogen sulfide doesn't stay in the water. It rises into the atmosphere, creating a toxic haze that poisons the air itself. On land, the situation is just as catastrophic. The volcanic winter from ash and sulfur particles blocks sunlight, causing plants to wither and die. Without plants, herbivores starve. Without herbivores, carnivores follow. But then, as the volcanic particles settle, the greenhouse gases take over, and the planet swings from freezing to broiling. The forests of scale trees that once covered vast areas begin to vanish. These weren't like modern trees. They were bizarre plants that looked more like giant bottle brushes, some reaching heights of 100 feet. As they die, entire ecosystems collapse. The insects that lived in them, the amphibians that hunted among them, the early reptiles that sheltered beneath them, all gone. But perhaps the most chilling aspect of the Great Dying is how it seemed to accelerate itself. As more organisms died, they decomposed and released even more carbon dioxide and methane. As forests burned, they added to the greenhouse gases. As ice caps melted, they reduced the planet's ability to reflect sunlight, causing even more warming. It was like a doomsday machine that fed on its own destruction. The speed of the extinction is what makes it so terrifying. While some mass extinctions unfold over millions of years, giving life time to adapt, the Great Dying happened in what geologists call an instant, somewhere between 60,000 and 200,000 years. That might sound like a long time to us, but in geological terms, it's a blink of an eye. In terms of evolutionary adaptation, it's impossibly fast. Species that had survived for tens of millions of years vanished overnight. Entire groups of animals that had dominated their environments became extinct so quickly, they barely left a trace in the fossil record. The trilobites, those iconic arthropods that had crawled across ocean floors for 270 million years, surviving for previous mass extinctions, finally met their end. Imagine creatures so successful they'd survived for longer than dinosaurs even existed, wiped out in what amounts to a geological moment. But some creatures managed to hang on by the thinnest of threads. In isolated pockets where conditions weren't quite as severe, small populations of survivors eked out an existence. These weren't the dominant species of their time. They were often small, generalized creatures that could eat almost anything and survive in harsh conditions. Among the survivors were the ancestors of the dinosaurs. Small, lizard-like archosaurs that would never have competed with the mighty therapsids under normal conditions suddenly found themselves inheriting an empty world. The great mammal-like reptiles that had ruled the Permian were gone, leaving ecological niches wide open for new groups to fill. the recovery from the Great Dying tells its own incredible story. For the first few million years after the extinction, the Earth was a biological wasteland. Fossils from this period show ecosystems so simplified, they're almost alien to us. Instead of complex food webs with dozens of species interacting, there might be just 3 or 4 species in an entire region. A plant, something that ate the plant, and maybe something that ate both. Scientists call these disaster taxa. Opportunistic species that could survive in the hellish post-extinction world. Many were small, fast-breeding animals that could take advantage of the lack of competition. Others were scavengers that could live off the massive amounts of dead organic matter scattered across the planet. But gradually, amazingly, life began to diversify again. The survivors evolved to fill the empty niches left by the extinct species. New forms appeared that had never existed before. The archosaurs split into several lineages, eventually giving rise to crocodiles, pterosaurs, and dinosaurs. In the oceans, new types of marine reptiles evolved to replace the vanished marine life. However, the world that emerged from the Great Dying was fundamentally different from the one that had been destroyed. The reef ecosystems of the Permian, with their complex carbonate structures built by bryozoans and brachiopods, were replaced by simpler reefs built by different organisms. The diverse forests of scale trees were replaced by the first conifers, and eventually by the cycads and ferns that would dominate the age of dinosaurs. The Great Dying essentially reset the evolutionary clock. It destroyed one version of Earth's biosphere and allowed an entirely different one to take its place. Without this extinction, there might never have been dinosaurs. There might never have been mammals as we know them. The entire trajectory of life on Earth was altered by this single catastrophic event. But here's where the story becomes truly unsettling. Scientists have found disturbing parallels between what happened 252 million years ago and what's happening now. The Siberian traps released massive amounts of carbon dioxide into the atmosphere over thousands of years. Human activities are releasing carbon dioxide at a rate that's actually faster than the volcanic emissions that caused the Great Dying. The ocean acidification we're seeing today follows the same chemical processes that dissolve the shells and skeletons of Permian marine life. The hydrogen sulfide poisoning, the marine dead zones, the rapid climate change. All of these have modern equivalents that are growing larger and more severe each year. Some researchers have calculated that if current trends continue, we could see similar levels of atmospheric carbon dioxide within centuries, not millennia. Of course, there are crucial differences. We're not dealing with continent-sized volcanic eruptions, and we have the advantage of understanding what's happening. But the fundamental mechanisms, the greenhouse effect, ocean acidification, ecosystem collapse, are remarkably similar. The Great Dying serves as a terrifying reminder of how quickly a thriving biosphere can collapse. It shows us that life on Earth, despite its incredible resilience over billions of years, can be pushed past a tipping point where recovery becomes nearly impossible for millions of years. Perhaps most importantly, it demonstrates that mass extinctions don't just kill individual species. They can completely restructure the entire fabric of life on Earth. The world that emerged after the Great Dying was not just a damaged version of the Permian world. It was something entirely new, shaped by the few survivors that managed to endure the planet's darkest hour. As we look at our modern world, with its own escalating environmental crises, the Great Dying stands as both a warning and a testament to life's ultimate resilience. It reminds us that while life itself will almost certainly survive whatever we throw at it, the world we know and the species we share it with might not be so fortunate. The next time you walk along a beach or through a forest, remember that you're experiencing something that almost didn't exist. You're part of a lineage of survivors that stretches back through the greatest catastrophe in Earth's history. And perhaps, if we're wise enough to learn from the past, we can ensure that the current chapter of Earth's story doesn't end the same way the Permian period did, with 90% of life vanishing into the fossil record, leaving only a thin layer of rock as evidence that an entire world once existed. The Great Dying changed everything. The question that remains is, will we let it happen again? The Great Dying wasn't the only time our planet nearly ended all life. There were 4 other mass extinctions that came terrifyingly close to wiping the slate clean, and each one reveals a different way our world can turn deadly. The asteroid that killed the dinosaurs? That was actually one of the smaller catastrophes. If you want to discover the other doomsday events that almost deleted life from Earth entirely, hit that subscribe button, because we're diving deep into every single mass extinction that nearly ended everything. Trust me, the stories get even more incredible and terrifying than what you just witnessed.